Hi, my name is Nuran Kifabita. Today, me and my groupmates will be explaining some certain questions about related rates and applied maximum and minimum problems for our group Calculus 1. Today, me and my groupmates, which is Alia Amani, Ahmad Zuraimi and Denji Farhan, will be doing an explanation for our group for MAT183. Let's start with what is differentiation. Differentiation is a method of finding derivatives or rate of change of a function. The rate of change of function is defined as dy dx equals to fx equals to y. A lot of application used for related of change. For example, we have two rates. Second is mean value theorem. Third is maximum and minimum. This topic will be guided truly by Akifa and Ayaman. Right, related rates, which is rate of change. Related rates problems involve two or more variables that change at the same time, possibly at different rates.
It's Alamani. So today I will cover question 1. So oars is flowing out from a vessel and forms a conical pile on the ground. The height of the cone is 3/4 times the radius of its base. If the radius of the base is 200 cm and the volume increases at a rate of 10,000 cm³ per second, find the increased rate of radius of its base. So in our step 1, we must draw a diagram based on the question and label the dimensions. So as you can see the question, it forms in the conical pile. So we can assume that it's in the cone shape somehow. And we must also label the dimensions. In step 2, we must write a formula for the volume that we will be using, which is a cone. And we also must extract all the information in the problems. So we can state the volume of the cone. The formula is what? You can see in my slide, and you can also state all the important information you can see in there. So we can find the height is equals to 3/4 radius, the radius is equals to 200 centimeters, and also the volume is also equals to 10,000 centimeters per second. So in here we already got the height, so we can just replace the height in our formula somehow. So after we already replace it, we can find our answer. This is not really our answer, but the formula that we will be using in the next step, which is 1/4 pi r cubed. Step 3, since we already extract all the information available in step 2, so right now we can differentiate it using implicit differentiation. So as you already see in my slide, I'm using chain rule, so that we can basically solve it using chain rule. So that is our answer. So since we already extract all the information, now we can solve all the question. Since they already stated all the volume is 10,000 cm³ per second, right? So we can put the volume in our formula somehow. So we know the volume. You also know the radius, so we can put like 3/4 pi multiply with 200 squared, since the 200 is the radius. So now we can just solve it like usual, and then eventually we get around 30,000 pi over 10,000. So right now, this is the most important part. You can switch it. You can switch their places, and then you can divide it. So once you already divide it, you can already found the answer for this problem, which is the answer is 1/3 pi for the increased rate of radius of its base.
Right, for question 2, a person is standing at the end of a pier 5 meters above the water and is pulling in a rope attached to a rowboat at the end of the waterline at a rate of 2 meters per minute. How fast is the boat moving in the water when it is 12 meters from the pier? First question, we have to draw the diagram based on the question and label the dimension. As you guys can see, I labeled the sides X, Y, and Z. Alright, for the second step, we have to use Pythagorean theorem because it's a triangle, and we have to extract the information. So we can solve that dz over dt is equals to minus 2 meters per minute. Why minus? Is because the distance between the rowboat and the pier are getting smaller. That's why it's negative. And our y is equals to 12 meters. Our x is equal to 5 meters, but we don't know our dy over dt. Alright, when we solve it using the theorem, it's going to be x squared plus y squared equals to z squared. That's our formula. When you substitute x, you only substitute x, it becomes 5 squared plus y squared equals to z squared. Solve it and you got z equals to 13. Right. For the third step, we have to differentiate using implicit differentiation. For the x, we only have to substitute for x. So it's going to be 5 squared plus y squared equals to z squared. The 5 squared is going to be 0 because when you differentiate constant, it's going to become 0. Plus 2y dy over dt equals to 2z dz. The fourth step, which is solve the differentiation. So we substitute y to 12. So it's going to be 12 dy over dt equals to z. Z is 13. Remember, we solved it. We got it from the theorem from the second step. So you substitute z to 13 and the dz over dt negative 2 because we already find it from the first place. So 12 dy over dt equals to negative 26 dy over dt. You solve it, you move it to the right side, and you got negative 13 over 6. Alright, we're on the next part, which is what is applied maximum and minimum problems. Alright, so the process of finding maximum or minimum values is called optimization. In calculus, it is used to determine the highest and lowest point of the curve in the graph, or known as the turning point. This topic will be guided truly by Amar and Danny.
Question 3 is, 4 meter of wire is to be used to form a square and a circle. Find the dimension for both the square and the circle that will minimize the total area, then determine the minimum area. That one is, I will draw a diagram based on the equation and label the dimension. After that, I will write a formula that is suitable and extract all the information based on the problem. After I got the equation, I will make x variable for the equation. After that, equation of x is variable into the area equation. After I got the final equation of area, I will differentiate it. After I differentiate the equation of area, I will make sure the dE dr is equal to 0. This is because I want to find the r. After that, the r is 2 over 5 plus 4. Then, when I get the r, I will use it to find the x. After that, I will differentiate it for the second time to determine whether it is maximum or minimum value. And I got it, the minimum value. After that, I will put the x and r value into the original area equation because I want to find the area minimum of this equation.
I'm going to explain about this question 4, which is a mirror in the shape of rectangle with an equilateral triangle attached to the top is to have a perimeter of 250 cm. Let x be the size of the equilateral triangle. Show that the area of the mirror is given. A equals to 125x minus with 6 minus square root of 3 over 4 and x squared. Hence, we need to find the dimension that will maximize area of the mirror. First step, we need to draw a diagram based on the dimension and label the dimension. From the diagram, we have 3x and 2y and the given perimeter, which is 250 cm. So we put in the formula. We're gonna have 3x plus 2y equals to 250. Then we're gonna solve it. So we have y equals to 125 minus 3x over 2. Then we need to find area of the mirror. So we have a equals to xy plus square root of 3 over 4 x power of 2 x squared. After that, we bring the y relay that we got to the equation. So we're gonna have a equals to x in bracket 125 minus 3 over 2x and plus with square root of 3 over 4 x squared. After we solve it, we're gonna have a equals to 125x minus with in bracket 6 minus square root of 3 over 4 and x squared. From the equation that we construct for the area, we can see it's same with the question asked us to prove, so we write shown there. So after that, we need to differentiate the equation. We're gonna have for the answer is 125 minus 3x plus square root of 3 over 2x. After we find the derivative, we need to equals it with 0. So we're gonna have 125 minus 3x plus square root of 3 over 2x equals to 0. So to make the denominator go on, we need to multiply all with 2 and we're gonna solve it. And then we have x equals to 58.5761. Then we need to make the second derivative from the derivative we got earlier. Differentiate 125 minus 3x plus square root of 3 over 2x. After differentiate, we have negative 3 plus square root of 3 over 2. So after solve it, we're gonna have negative 2.1340. So we got the maximum because it negative. Then we bring x to the formula, so we have 250 minus with 3 in bracket 58.5761 over 2. So after solve it, we're gonna have 37.1354 centimeter. After that, we need to find the maximum area using area expression. So A maximum equals to xy plus square root of 3 over 4 x squared. And then we bring the x and y that we got earlier. After solve it, we're gonna have 3661.0118 centimeter square. Then we put it back to the original equation.
Alright, so in conclusion, therefore identifying the right formula and accomplishing both first and second derivatives correctly will lead to a solid answer to find your maximum. And for our references, we use the Calculus 1 textbook, International Metric Edition, which is the 11th edition, and we also took notes and workbook by our Miss Bahaya Awang.